All right, so Module 11 deals with something called implicit differentiation. So our objective is to find the derivative of complicated functions by using implicit differentiation. And then we're also going to use implicit differentiation to determine the equation of a tangent line. So we use implicit differentiation for a couple of reasons. One, we use it when it's difficult to isolate the variable y. So for instance, if we had the equation y squared plus x squared is equal to 25. So to differentiate that and to try to use the method that we've utilized for an explicit function, and when I say explicit, I just mean we have a straightforward y equals type equation with only one variable on this side. So to try to use this method, we would have to solve this equation for y. So we'd have y squared equals 25 minus x squared, and then we'd have y equals plus or minus the square root of 25 minus x squared. So you can see how that would quickly become tedious with that plus or minus. So we're going to use a method called implicit differentiation instead of our traditional method. All right, so here you'll find just some strategies that you can utilize with implicit differentiation. So the basic idea is that you take the derivative of both sides and then rewrite the equation and isolate dy dx. So you want everything with dy dx on one side and everything that does not have a dy dx on the other side. And then if necessary, you'll factor out a dy dx, and then we will solve for it. So it's easier to see utilizing examples. So on this first example, we have x squared plus y squared equals 25. And we need to calculate the derivative of y with respect to x. So we're going to take derivative with respect to x of x squared plus y squared equals 25. So you want to derive both sides. So on this side, derivative of x squared with respect to x is easy. That's just 2x. Derivative of y with respect to x, we would derive y, but then we also need to make sure that we continue with dy dx. We do that because of the chain rule, and also if you think about u substitution, whenever we solve a problem, say like y equals sine of 2x, and we use u substitution, so u is equal to 2x, du dx is equal to 2. And when we differentiate with respect to x, u, remember derivative of sine is cosine u times, we have to multiply by our du dx. So same idea here. So the thing to just keep in mind, whenever you differentiate y with respect to x, you need to add in this dy dx. That's the big takeaway on that. And then the derivative of a constant is still 0. That has not changed. So again, we want to isolate dy dx because that's what we are solving for, the derivative of y with respect to x. So we are going to keep everything with the dy dx on one side and everything without a dy dx, move it to the other side. So this last step here is to divide by 2y. So this gives us a negative x over y. So we can find the rate of change of this function using the equation, the instantaneous rate of change using this equation, negative x over y. And if you think about it, x squared plus y squared equals 25. What is that the equation of? So that's the equation of a circle that has an origin of 0, 0, and a radius of 5. So this equation here is going to give you that rate of change as you move along that circle. Okay. So another example, in this one we have to utilize the product rule. So we have x cubed sine y plus y equals 4x plus 3. So again, we are going to derive both sides with respect to x. Okay, so here we need to use the product rule. So remember our product rule, we take the derivative of the first function times the second function plus the derivative of the second function times the first function. So the derivative of x cubed, that's 3x squared, and then times sine y, plus, I didn't derive y here, I just simply copied it down, so I don't need a dy dx. Now we take x cubed times the derivative of sine y, which is cosine y, but again, I'm deriving with respect to x, so I need to add in that dy dx. Derivative of 4x is 4, derivative of 3 is 0. So now our next step is to keep everything with the dy dx on one side and move everything else to the other side. So that's going to leave us with x cubed cosine y dy dx is equal to 4 minus 3x squared sine y. So then we're just going to divide everything by x cubed cosine y. And that's the derivative of y with respect to x. Same method can be utilized to calculate second derivatives. So if we take the same problem that we did earlier, remember dy dx was equal to negative x over y. Let's just double check that. Yep, negative x over y. So if we want to derive that again, that's going to take care of that, and then d dx. So we would have to use the quotient rule. So the derivative of x is 1 times y. That gives us y. Remember, quotient rule, we subtract, and then we take the derivative of the denominator, which is 1. But remember, we're deriving a y, so 1 times dy dx times x. So if we, again, we're calculating our second derivative. So in this problem, we know what dy dx is equal to. It's equal to negative x over y. So we're going to want to substitute that in. So y minus negative x over y times x. So that gives us y plus x squared over y. And then if you wanted to have a common denominator here, you could do that. X squared plus y squared over y. Okay, so now find the equation of a tangent line to a circle. So again, same problem, but this time we're going to take it one step further. We're going to go ahead and find the equation of a tangent line at a specific point. So we have an ordered pair that exists on the graph. If at any time you're only given the x-coordinate, you can always plug it back in to evaluate your y-coordinate at that point. So we know already, because we've calculated this a few times, that the derivative of that is equal to negative x over y. So we can use our ordered pair, because we're interested at that point, 3, negative 4. We're going to plug in 3 for x, negative 3, and negative 4 for y. So that gives us 3/4. So we know that our equation of a tangent line is going to have a slope of 3/4. We now just need to figure out our y-intercept. And again, we have a point that the graph passes through. So we're going to just plug those points in. So that gives us negative 4 is equal to 9/4 plus b. So negative 4 minus 9/4, common denominator is 4, So negative 16 minus 9 is negative 25 over 4. So that equation, I'm going to replace that b with negative 25 fourths. So that gives us our equation of the tangent line.